so today's math video is brought to you by Quest Crispy Blueberry Cobbler Bars and the letter 4. All right, so did I already have what? That's the one I've been eating. Where are you at? Put it back on the video. This. What is he smoking? Why is what blue? Oh, you mean why is the color a little bit different? Oh, it's just the way the camera does. Oh. Tripping so hard. Okay, no. That's why I don't use my yellow and my orange, excuse me, my pink and my orange pins together, because the ink looks identical under the camera. But to the eye, they're completely different. Yeah. Anyway, I was trying to do some math. So, modeling periodic behavior, word problems, trig-based word problems, part 1. There will be a part 2. One of the, oh, by the way, these scenarios, ridiculous. Okay, I didn't make most of them up, just so you know. One of the largest sewing wheels in the machines in the world has a wheel that is 5 feet in diameter. That's a really big sewing wheel. The highest point on the handle at the edge of the wheel is 9 feet above the ground, and the lowest point is 4 feet above the ground. That should make sense since you have a diameter of 5, right? The wheel makes a complete turn every 2 seconds. Our job is to write a model for the height, h, in feet of the handle as a function of time, t, in seconds, given that the handle is at its highest point at time equals 0. That was a lot of stuff. I do very well with pictures, very poorly without them. So I'm gonna draw a picture. Of course, picture not drawn to scale. So here we go. We have a sewing wheel and the ground. All right, we have a sewing wheel on the ground. What do we know? We know that the diameter of the wheel is 5. The highest point on this wheel is at 9 feet. And since the diameter is 5, we know the lowest point is 4 feet above the ground. What's the radius then? What? 2.5. Yep. Sound like somebody said 3.5. 2.5. And another bit of information that you were given was you were actually told the period length. 2 seconds. Because it says it completes 1 turn every 2 seconds. So our period equals 2. Cool. We need to come up with an equation for this system. And I do really think that the easiest way to do this is to draw a sketch of the graph, plot out some of its points. It says at time equals 0, it is at its highest point. Lowest point is 4, highest point is 9. At time equals 0, we're at its highest point. Because the period length is 2 full seconds later, it's going to be at its highest point again. So when is it at its lowest point? What's halfway between 2 maximums? A minimum, so it's at its lowest point at 1. And that means we can do this as well, because that is where we're going to be on our midline. Remember, halfway between a maximum and midline is always halfway between a maximum and a minimum is always a midline hit. So there is a midline here. And we're going to hit it at ½ second and 1.5 seconds. There's our graph. Oh, okay, well, what's halfway between 9 and 4? 6.5. Strange. That's exactly 2.5 above 4. That's not strange at all. I think we're ready to write an equation here. Is this a h? Yeah, height. H of t. Height over time is, first of all, shape of this graph. Is it shaped more like a sine wave or more like a cosine wave? Shaped more like a cosine wave because it begins at a maximum just like a cosine wave would. What is its amplitude then? 2.5. Okay, in word problems like this, the amplitude is always the radius, always. If you think about it, the radius is going to tell you how far away from the center you could go, above it and below it. So the radius will always be our amplitude. Cosine is supposed to begin on the y-axis. This one did, which means we do not have a phase shift, so I don't have to have any pluses or minuses inside my argument. And I left space there for a reason. What is the vertical shift? What is the midline? 6.5. The center of the circle, the height of the center of the circle will always be the midline. Always. Same reason why the radius will always be the amplitude. The only thing that's left for us to do is to figure out what number, what b value had to be in front of our variable. And we know how to find it because we know that the period is 2 and the equation for period length is 2 pi over b. What's wrong? Oh, okay. I know that 2 pi over b equals 2. And again, I hope you can see that the answer is pi. But if you couldn't, remember when you're trying to isolate this b value, these two things just switch places. So you get that b equals 2 pi over 2, which is pi. And that is one equation that will work for this. All right, the intrusion from the yearbook people is over. Moving on, moving on. Now let's talk about a Ferris wheel. Let's talk about a Ferris wheel. Good Lord, I'm gonna have to pause the video because these dinglings won't stop talking. I'm gonna throw a pin at Holly. Exactly. All right, so what? That's the answer. What do you mean? What's the answer? It says write an equation. I've been talking for like 3 solid minutes about like to get back to work. I just said these dinglings won't stop talking. I wish I could throw. I'm gonna throw a pin at Holly. It's all on video. Yeah. Yeah. You asked Jewel. Hey, by the way, Jewel gave me big thumbs up for my air quotes. She said they were on point. So anyway, it was a text message. I have comments turned off. So I don't want to develop an eating disorder, so I can't take a hit to my confidence. A Ferris wheel with a radius of 25 feet is rotating at a rate of 3 revolutions per minute. What happened? What did she say? Why am I? No, they deserve to hear this. What's happening? What about it? Dang! You know, Holly said I have fat fingers. Dang! I'm going to use this video as evidence when they finally figure out why I snapped and showed up smashed at school. Anyway, so yeah, three fat fingers. All right. I know, right? I'm gonna use pointers from now on, like. Okay. Okay, back to the math. Anyway, we got to do this. We got to do this. Oh yeah, those little mini hands like that woman on TikTok with the little hand on a stick. I hate her. All right, so a Ferris wheel with a radius of 25 feet. Radius 25 feet. We know our amplitude is rotating at a rate of 3 revolutions per minute. That's our period length. When time is 0, a chair starts at its lowest point. Okay, so this time we're starting at our lowest instead of our highest. And that lowest point is 5 feet above the ground. We're going to write a model. Same deal. So same picture. Ferris wheel, picture on scale, ground. Wow, that's not even centered. We know that the radius is 25. And we know that its lowest point is 5 feet above the ground. So what is its highest point? 55. 50 didn't say 30. Yeah, because it's 25 and 25. So its highest point is 55. Since we know it's going to be important, what's halfway between 55 and 5? It's also known as the average. Wow, IB students, it's 30. Okay, yeah, it's 30. The average of 55 and 5 is 60 over 2. It's 30. I know, right? Basic math. We know that the period length is 3 per minute. Be careful. The question's in seconds. Your period length is in minutes. So 3 minutes is 180 seconds. Cool. So we actually have a period length of 180. 2 pi over b is 180. So b is 2 pi over 180, or pi over 90. There. We're ready to rock and roll. The only thing I would say is still take the time to draw a quick sketch of the graph based on the information that you were given. Real quick. We know 180 is out here. We know its minimum is 5, its maximum is 55, midline is 30. Cool. It says, because when you get on a Ferris wheel, the gondola is at the bottom. That's what that's called. It's called a gondola, yeah. It's at the bottom, which is your minimum. So after 180 seconds, it's at its minimum again. Halfway between minimums is a maximum. Halfway between those is going to be your midline hits, so at 45 seconds and so on and so forth. But the reason why we went ahead and sketched it is that we could see what kind of wave we're looking at. What kind of wave suits this really well? Negative cosine, because it's upside down. So, what's that? Negative cosine? Oh, you looked it up? Passenger cars, cabins, tubs, pods. I like gondolas. It sounds fancy. What does this want us to do? Height. Same thing. So height over time in seconds is, we said, negative radius, because that's amplitude, cosine of, once again, since it starts on the y-axis, not phase shifted. So it's just pi over 90 t plus 30. Boom, there it is. Of course, if it had told us we had to write it as a sine wave, that would be phase shifted. At what time does a positive sine wave begin? Right, what time though? On the graph, yeah. Not somewhere, we know it's exactly halfway between. 45 seconds. Picture not trying to scale, remember? But we do know that halfway between a maximum and a minimum is a midline hit. It didn't dictate that we had to use a sine model though, so that's the best one as far as I'm concerned. So this one is not, the next one is not a Ferris wheel or a sewing wheel. It's clock. Yeah. So the hour hand of the large clock, oh, by the way, remember, I didn't make these questions up, okay? The hour hand of the large clock on the wall in Union Station measures 24 inches in length. At noon, the tip of the hand is 30 inches from the ceiling. Okay, I'm just going to go ahead and start drawing this picture. We got the ceiling. We've got a clock. We know at noon, it's going to be pointing up because that's where noon is. And we know that this number is 30 from the ceiling inches. And it says that the hand itself is 24 inches. That means the radius is 24. Then what's its minimum going to be? So Natalie said negative, and you said 6. Well, why are you guys making these numbers go down instead of up? So you're saying because it's below the ceiling. If that was the case, then wouldn't you have wanted to make this negative 30? From the top, yes. But then this would be even more from the top, wouldn't it? 78. But what I'm getting at here is if you wanted to make this negative, you could. Because it's under the ceiling, you could do that. But there's no reason to because the question says it wants a function that models the distance of from the hand to the ceiling. So we want those numbers to be positive. Yeah, what's up?
The hand does not touch the top of the clock. There's like an inch of space.
Have you seen a picture not drawn to scale?
But the question is
Yeah, I was just drawing a circle. That doesn't represent the clock. That represents where the numbers are. I'm totally making this up. I just wanted you to make a picture that was easy. All right, what else do we know? Let's see. It says at 3 p.m. it's 54 inches from the ceiling. That was nice of them. They just told you this distance, or excuse me, this height, which means you know your midline because that's 3 clocks directly to the right. So you have your minimum, your maximum, your midline, your radius. And let me ask you, what's the period length? 12. Period length is 12, right? Because there's only 12 numbers on the clock. Just find a cosine function and a sine function that model the distance of the tip of the hour hand from the ceiling. So the period is 12. Let's go ahead and solve for B. There, B is pi over 6. And then we are ready to get what? No, because our y values will be distances from the ceiling, so we can allow them to be positive numbers. It's 30 inches from the ceiling, 50 inches from the ceiling. All righty. Minimum is 30. I don't know if the homework is a lot, but if it is, you've got a couple days. Today's Thursday, right? Okay, well, the homework's obviously not due till Monday, so Thursday night, Friday night, Saturday night, Sunday night. You all said the same thing. That was weird. Oh, not Saturday night? Oh. You're lucky it's not longer. So period length is 12. Throw a 12 out here. Cut that number in half is a 6. Cut those numbers in half, and you get those. All right. And it says at noon. Well, noon would technically be 0 hours, right? At noon, it's at the 30. So at 12, it'll be there again. 6, it'll be halfway between. That looks just like the last picture. So negative cosine is the easiest way to write this equation. We want to say distance over time is negative because it's a bell shape, it's upside down. Radius is 24, so that's amplitude. Cosine of, well, cosine's supposed to start on the y-axis. This one does if we call it a negative cosine wave. So no phase shift. Pi over 6t plus 54. That's the easiest answer. But the directions were to find a sine wave and cosine wave. There's cosine. We need sine now. Now there are an infinite number of correct answers, but on this picture, where do you see a positive sine wave beginning? At what x value? At 3. So if we wanted to do that, we do have to have a phase shift. A positive sine wave starts at its midline and goes up. There is a phase shift though. The pi over 6 stays out front of the t, but it has been shifted to the right 3. This isn't a 31, this is parentheses. There you go. That's what? Oh, it's a loud clock? Oh, I thought you were talking about the clock in the question. So there you have it. Sometimes the type of model is dictated to you. Sometimes it's not. I will confess that I made up this question. What? I'm sorry? Oh, because it shifted to the right 3 for positive sine wave. Okay. I made this question up. We're going to get as far as we can before we have to call it. Ooh, I wonder if that showed up on mic. My stomach just growled. Because I made it up, the story sounds a little ridiculous. I'm sorry, just go with what? Okay, they're staring at a video, she's texting, they're playing hand clappy games. What the heck? The following, can you hear my disappointment? I hope they can hear my disappointment in the video. The following diagram represents a paddle wheel on a steamboat. Points P, Q, and R represent different positions on the paddle wheel. The wheel has a radius of 10 feet. It rotates clockwise at a rate of 1 revolution every 36 seconds. A paint mark, because I couldn't think of anything better, starts at point P. So for some reason, you're standing on this boat or standing on the coast. I'm not sure. Riverbank, probably a riverbank. The point is you're watching this wheel go around and there's a piece of paint that you're looking at as it spins around. The dotted line represents the water because it is a paddle boat. So at some points in time, the paddles are in the water. That's why they work. Great. It says after 4 seconds, because it started at P, after 4 seconds, this point is at Q. What is the depth at point P? And you do have enough information to solve this. Before I go ahead and tell you how to do it, anybody in the room think they have an idea? Or any ideas or strategy? Huh? You spy a triangle? Yes, 100% agree. More specifically, it's a right triangle. What do we know how to do in right triangles? Trig! Yay! But you know what trig normally requires? Angles, doesn't it? Well, you do know how long this is. Because that's vertical and that's horizontal. Anyway, he's right. It doesn't say that, but like I said, I wrote the question myself. We do know that the radius is 10. If only we knew an angle. Well, you know that, but what good is that going to do you? I'm sorry? Yeah, but again, sectors are going to require angles, aren't they? Oh, okay. It takes me 4 seconds to get from here to here. And why is that useful information? No, it's not the arc length. It's the arc measure in time, but you need degrees. So why is the 4 seconds necessary? I'm sorry? But you don't know the y value at those 4 seconds, do you? Well, I mean, you know it's 0, but you don't know where it began. Ah, there it is. It takes me 36 seconds to get all the way around this circle. So you are 4 over 36 of your way through a whole circle, which means you are 4/36 through the 360 degrees. Four over 36 times 360 degrees is 40 degrees. I know because the 36 and 36 cancel and it leaves me 4 times 10. 40 degrees. We can use that information along with this information to figure out some stuff, can't we? Because how long is this? 10. So once I find this number, I can subtract it from 10 to figure out how far down P is. This number we'll call a y value because it's vertical, and we will need our graphing calculator for this. From 40 degrees, this is your adjacent side, so we're going to be using cosine. Cosine of 40 degrees equals y over 10. Our y value then is 10 times the cosine of 40 degrees. We want to make sure that our calculator is in degree mode. Mine is. So 10 cosine 40 degrees is 7.66 to 3 sig figs. That means P is 10 minus that, 2.34 feet underwater. So yeah, that was the big leap in logic there, is using the fact that it takes 36 seconds to get all the way around, and you've only used 4 of those seconds. You've done 1/9 of a period, which means you've gone 1/9 of the 360 degrees. That was the leap in logic. It says find the height of the paint mark above the surface of the water after 18 seconds. Okay. What's significant about the number 18? It's half of 36. So where would we be if we started at P 36 seconds later, or 18 seconds later? The maximum. That's going to put us way up here. Well, we know that this number is 10. So its height is just going to be our y value plus 10. Which is going to be 17.66. I just added 10 to that number right there. Part C wants a sign model for the situation. What? Okay, don't rush me. Let's fill it out. And the way we're going to do that is plotting some points. We know it took us 36 seconds. So that's an 18, that's a 9, that is a 27. And this one actually dips below into the negatives. So it goes all the way down to negative, picture not drawn to scale, 2.34, goes all the way up to 17.66. The midline is 7.66. It starts at a minimum. That means it ends at a minimum. Halfway between the minimums is a maximum. And halfway between a minimum and a maximum is a midline. We have this picture, which is, wow, that was bad, which is once again negative cosine. But a positive sine wave was specified. We need to know the phase shift for a positive sine wave to begin. Where would that have happened? At 9. So this right here represents our C value. What is the vertical shift? 7.66. That's the D value. All we need to know now is B. And B determines our period length. We know that the period, which is supposed to be 2 pi over B, is 36 seconds. So B is 2 pi over 36, which is pi over 18. That gives you the ability to write this equation completely filled out. H of t equals 10 sine of pi over 18 times t minus 9 plus 7.66. And question D says, find the first time it's 11 feet above the water. 11 would be here-ish, picture on a trumpet scale. Okay, so you know the answer is somewhere between 9 and 18. How are you going to find that answer? I'm sorry? Second trace intersect. You set this equation equal to 11 and do second trace intersect. You do not get any bonus points for trying to solve the trig by hand. You write this to get your method mark and second trace intersect to get the result. Make sure your graphing calculator is in radian mode before you try to graph. And I'll just write down the answer because I'm going to assume that everybody knows how to do second trace intersect. It's 10.95 seconds. There it is. All right, part 2 tomorrow.